And I think we've got kind of like one major hardware revision, which should be done by end of this year or early next.
Completing the hardware is a crucial step for Tesla Optimus to adapt to and effectively handle a wide range of household tasks. Precision in design allows the robot to operate smoothly, saving users both time and effort. So, how will the improved design enhance Optimus's performance? Before we begin, please help us reach 8,900 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. How does the power supply system of Tesla's Optimus work? Tesla is currently using its familiar 4,680 battery cell to power the Optimus robot, but not everyone agrees that this is the most optimal choice for a humanoid robot. While the robot's body is large enough to accommodate these oversized battery cells, achieving the necessary voltage level around 48 volts requires Optimus to use about 90 cells. Tesla has revealed that the total battery capacity is 2.3 kilowatt-hours, which is enough for the robot to operate continuously for 12 hours in a home environment, from walking around the kitchen and cleaning the living room to assisting in child or elderly care. After 12 hours, Optimus can autonomously return to a home charging station to recharge. The charging time is just about 1 hour, after which it can resume work. Since it is a robot, it doesn't need rest like humans, and can operate all day as long as it's recharged in time. Tesla chose the 48-volt level because it's considered safe for human interaction. Higher voltages could be dangerous in close contact environments. However, to ensure stable operation and provide redundancy in case some cells fail, Optimus will likely require a modular battery system dividing the battery into multiple 48-volt packs, connected in parallel. This approach boosts power output, improves replaceability, and is safer in case one module encounters an issue. With the 4,680 cell offering around 26 amp-hours, using two 48-volt modules is enough to reach the 2.3 kilowatt-hour total. If smaller cells like the 2,170, around 5 amp-hours, were used instead, about 10 modules would be needed, making the system more complex, taking up more space and increasing costs. Therefore, using large cells like the 4680 remains a sensible solution, especially since Tesla has full control over large-scale production at Giga, Nevada. Inside the factory, Optimus will face much more demanding tasks than home cleaning, such as lifting heavy objects, tightening bolts, and inspecting components so the battery will drain faster. However, thanks to fast charging technology, it only takes about 30 minutes for the robot to recharge enough to resume a shift. Tesla may also implement a rotation model. While one group of Optimus units is working, another group recharges, ensuring the production line runs without interruption. Another interesting aspect is that Tesla may be integrating a regenerative energy system. This means when the robot lowers an object or moves slowly, some excess energy can be recovered and fed back into the battery. This helps extend the operating time without increasing battery size. Moreover, Optimus's battery management system is integrated with AI. That means the robot can adjust its power consumption depending on the task, using less energy for light tasks and ramping up output for heavier ones. This is a major differentiator compared to rivals like Figure AI or Boston Dynamics, which still rely on traditional battery systems. In the future, Tesla may also experiment with solid-state batteries for next-generation robots. These batteries are smaller, lighter, store more energy, and generate less heat. If that happens, Optimus could operate twice as long without adding weight, extremely beneficial for industrial or service environments. In summary, although there is still some debate around using 4,680 cells for Optimus, given Tesla's long-term strategy and in-house battery production capabilities, this is a technically sound and cost-effective move. Once again, please help us reach 8,900 subscribers. This is important for us to stay motivated. Thank you. What changes have been made to Optimus's charging system? At first, many assumed that Optimus would share the same charging system as Tesla's electric vehicles like the Model 3 or Cybertruck. However, reality turned out to be completely different. In the testing video released by Tesla, Optimus is shown using a dedicated charging station, minimalist in design and highly mechanical in nature. Interestingly, when the battery level drops to 15%, the robot proactively stops working. The LED light on its head turns red as a warning signal, and it automatically activates its navigation system to seek out the nearest charging dock. What surprises many is the location of the charging port. It's on the back, not on the side or near the legs as previously speculated. This means Optimus must rely entirely on its cameras and visual sensors to precisely locate the charger and align its body so the charging connector can dock accurately, a process that must be both fast and gentle to avoid damaging the port. Tesla clearly put a lot of effort into this aspect, as even a misalignment of just a few millimeters could prevent the robot from charging or cause wear on the connector. Once fully charged, the LED turns green, signaling that the robot is ready to resume its tasks. Optimus then autonomously unplugs and continues working without any human intervention. This entire process happens automatically, as if a diligent employee knows exactly when to take a break and when to return to work. One particularly unique feature of the charging system is that it's not just a stream of electricity flowing in. It's controlled by finely tuned algorithms that adjust the current based on the time of day, battery temperature, and even the robot's usage history. Thanks to this, Optimus can charge quickly, without degrading battery lifespan, while always maintaining stable performance when it returns to work. This self-charging mechanism is reminiscent of the plug-and-charge system used in Tesla's Cybercab models, but it has now been adapted for humanoid robots, a major leap in flexibility. Imagine a home or factory where Optimus roams freely, locating chargers whether embedded in a living room wall or tucked away in a factory corner, and recharging itself as naturally as a human grabbing a drink of water after tiring. Even further, Optimus's system goes beyond smart charging. It enables shared learning. Just like people exchange messages in a group chat, every time an Optimus learns something from avoiding an obstacle to optimizing movement in tight spaces, that knowledge is synchronized across the entire robot fleet. This means every Optimus improves together without each needing to learn from scratch. Thanks to this group learning capability, if one Optimus in the Texas factory encounters an unfamiliar situation and solves it, just minutes later, an Optimus in Berlin or Shanghai will know how to handle it too. Tesla refers to this as collective learning, a form of decentralized AI with rapid, cross-updating ability. At present, only Tesla can execute this at such a large scale because it owns the full stack: computing infrastructure, hardware, and real-world data. The ability to share movement maps, reflex behaviors, and even job-specific tricks means Optimus is not just a robot that works, it's a living part of a continuously learning ecosystem. This becomes especially valuable when Tesla deploys thousands of these robots across factories, where each Optimus has its own role, but operates in harmony with the rest like a well-synchronized team. In a real-world scenario, one could imagine hundreds of Optimus robots working in shifts unfazed by breaks, fatigue, or emotional lapses. Whenever energy is low, a robot silently retreats to the rear, while another steps up to take its place, ensuring the production cycle never breaks. As a result, productivity could increase dozens or even hundreds of times compared to traditional labor models. All of this happens in silence, with order, and with astonishing precision. The charging system, data connectivity, and self-adjusting capabilities of Optimus are not merely technological upgrades. They form the backbone of Tesla's vision for a fully autonomous robot workforce. This marks the beginning of a new era in automation, where machines don't just perform tasks, they learn, adapt, and evolve as part of a dynamic living network. How does Optimus Gen 3 communicate with humans? One of the most significant upgrades in Optimus Gen 3 is its ability to communicate via voice, a feature confirmed by Elon Musk for the new version. This marks a major leap from Optimus Gen 2, which operated silently with limited interaction. With storytelling capabilities, advice-giving, and casual conversation, the robot becomes not only easier to control, but also closer to being a genuine companion in everyday life, something most robots on the market today have yet to achieve. Optimus Gen 3 is equipped with a 7-inch touchscreen on its torso, providing an intuitive, interactive interface. Its voice control system supports up to 15 languages and features a speech recognition accuracy of 95%, along with gesture analysis capability reaching 90%, enabling it to comprehend body language as well. This is particularly useful in home or healthcare settings, where understanding a user's intentions, both verbal and nonverbal, is crucial. This gives Optimus a clear edge over competitors like Figure AI or Digit, which emphasize locomotion but lack depth in human interaction and communication. Beyond simply understanding and responding, Optimus Gen 3 can adapt its behavior to individual users through integrated AI models. This allows the robot to adjust its tone, attitude, and speech style based on the user's age, circumstances, and emotional state. For the elderly, it can speak in a calm, soothing tone, remind them to take medication, or share nostalgic stories. For children, it can be lively and playful, telling fairy tales or interacting as a learning and play companion. This level of personalization far surpasses platforms like Alexa or Google Assistant, positioning Tesla as a pioneer in the personal interactive robot space. This adaptability makes Optimus an ideal choice for households, where it can act not only as a support tool but also as a companion, caregiver, and even emotional therapist. With rapidly aging populations, especially in developed countries, the need for empathetic, supportive, and communicative devices is growing. Optimus can help the elderly monitor their health proactively, deliver timely reminders, and ease loneliness by providing someone to talk to. For children, it can serve as a learning assistant and playmate, opening up vast potential in interactive education. Compared to its current competitors, Optimus Gen 3 is clearly ahead thanks to the seamless integration of hardware, software, and artificial intelligence. Figure AI's Figure 01 has achieved walking and object handling capabilities, but lacks a voice communication or behavioral system. Boston Dynamics Atlas impresses with complex mobility, but it doesn't focus on human communication or emotional understanding. Even service robots like SoftBank's Pepper, though capable of basic conversation, remain limited to simple responses and cannot tailor behavior to individual users. Tesla, on the other hand, leverages its immense AI training ecosystem, from billions of kilometers of autonomous driving data to home cameras, smart devices, and image recognition technology, to build a robotic platform that understands and learns more like a human than any competitor. Optimus Gen 3 is not merely a communication robot. It also serves as the control hub of a smart home. Integrated with the Tesla home ecosystem, the robot can connect with and control lighting, air conditioning, door locks, curtains, heating systems, security cameras, and even Powerwall energy storage units. This turns Optimus into a context-aware smart butler, automatically closing windows when it rains, opening curtains at sunrise, or issuing alerts when unfamiliar individuals are detected. This holistic vision far exceeds that of current rivals, which mostly focus on movement or isolated reactions. From a socio-economic perspective, the arrival of Optimus Gen 3 signals a transformative shift in how humans approach labor and caregiving. If Tesla can produce 10,000 units annually and gradually reduce the cost to below $20,000 per unit, then deploying just a few million units could establish a trillion-dollar robot industry. In sectors like healthcare, education, retail, and in-home services, a robot capable of intelligent communication, emotional awareness, and task efficiency would significantly reshape labor structures, especially in countries facing labor shortages. Milan Kova, a software engineer at Tesla Robotics, shared on X that Optimus Gen 3 is rapidly improving through full simulation training with reinforcement learning. The sim-to-real system has been optimized with key updates. The cable is only a safety precaution and doesn't affect performance. Early results show Tesla Bot is nearing high stability and refinement. What makes Optimus Gen 3 improve so rapidly in such a short time? Before we begin, please help us reach 8,200 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Model Q, Tesla EVs, and the latest news. What is Tesla aiming to achieve by training the Optimus robot through simulation? Tesla is taking a very modern approach to training the humanoid robot Optimus, training it entirely in a simulated environment using reinforcement learning (RL). This is a type of machine learning where the robot explores and improves its abilities through trial and error in millions of different simulated scenarios. What are the practical benefits and significance of training fully through simulation with reinforcement learning, RL? In reality, simulation training offers huge advantages, especially in saving time and costs. Instead of building complex physical models and testing each one, Tesla can quickly adjust factors in the virtual environment to try out various operational strategies. As a result, the improvement process becomes much more flexible, faster, and more efficient. Compared to other companies developing humanoid robots like Boston Dynamics with their Atlas robot, Tesla aims to accelerate progress by heavily investing in computing infrastructure and software. While other robots might take months or even years to master a basic skill, Tesla believes simulation can significantly shorten the stage. Every algorithm update can be tested immediately in the virtual environment without waiting for the physical robot. This is why Tesla is confident they can speed up the commercialization of Optimus, aiming for mass production in the near future. However, training and simulation does not mean the work is done. There is another crucial step called sim-to-real transfer, which means transferring the skills learned in simulation to the real world. What role does optimizing and fixing errors in sim-to-real code play in robot development? In practice, the real environment always contains uncertainties and differences compared to simulation. If a robot is only good in virtual environments but clumsy in real life, it is useless. That's why Tesla focuses heavily on optimizing sim-to-real code, minimizing the gap between what the robot learns in simulation and what it can actually perform in reality. If not well handled, the transfer error can reach 20 to 30%, causing the robot to walk unsteadily, grasp incorrectly, or lose orientation. Therefore, Tesla continuously updates, patches, and refines the sim-to-real code to help Optimus work more smoothly and reliably in the real world. Another difference is that Tesla is not just targeting robots for warehouse or factory work like Figure AI or Agility Robotics, but wants to create a robot that can adapt to human living environments, from homes to factories. This makes their sim-to-real challenge far more complex because the robot must handle many unpredictable situations. Carefully fine-tuning the transfer from simulation to reality is the key for Optimus to function well in diverse environments. In Tesla's test videos, many have noticed that Optimus is supported by a cable during trials. Why does Tesla use support cables in the early testing phase, and how does it affect development? Actually, using support cables is very common in the humanoid robotics industry. The main purpose is to prevent serious damage to the robot while it is learning to walk, lift objects, or maintain balance. Tesla also clearly explains that the cable is not to hold the robot still, but to prevent falls when control is not yet stable, especially in the early unstable phase. The cable makes testing safer and smoother. Thanks to this, the development team can check many difficult movements without worrying about time-consuming repairs or reassembly after every fall. Boston Dynamics used this method when training Atlas, especially during flips, parkour, or moving over complex terrain. For Tesla, using cables is not only to protect hardware, but also to collect more accurate motion data that will be very valuable later for improving control algorithms. Looking more broadly, the support cable also reflects Tesla's careful and strategic caution. They are not rushing but building solidly step by step. With this safety net, Tesla can upgrade software and perfect hardware simultaneously without interruptions when the robot encounters errors or malfunctions. This is the foundation that helps them soon reach the stage of testing without cables and be ready for mass production. Once again, please help us reach 8,200 subscribers. This is important for us to stay motivated. Thank you. What advancements in Tesla Bot Gen 3 during the present phase highlight Elon Musk's pride? Elon Musk calls Tesla Optimus the biggest product ever from Tesla, a humanoid robot designed to perform factory work and personal assistance, promising to usher in a new era of automation. Musk is confident that Optimus will scale faster than any product in Tesla's history, targeting production of up to 1 million units annually by around 2029 or 2030. This plan shows an ambition not just to remain at the experimental stage, but to popularize robots in industry and everyday life at an unprecedented scale. At Tesla's Palo Alto laboratory, clear technical progress has been recorded as Optimus can move autonomously in the office, self-charge, and perform tasks flexibly. This not only demonstrates mobility, but also operational autonomy, an essential factor for robots to work effectively in real environments without continuous supervision. This forms the foundation for the rapid expansion Musk mentioned. In a discussion with Microsoft CEO Satya Nadella, Musk emphasized the practical foundation for robot development. Robotaxi needs to drive safely and precisely, while Optimus must complete assigned tasks accurately. This reflects Tesla's clear vision that robots should not only be demonstration technology, but also meet safety standards and practical performance to deliver real value to users. Tesla actively showcased Optimus at the We Robot event, with performances serving drinks, customer interaction, and intricate dancing, proving coordination of complex movements and improvements in mechanical and software motion control. The latest dance videos released by Tesla show the robot increasingly demonstrating softness, precision, and flexibility, signs of breakthrough progress in refining control algorithms and mechanical structures. Regarding production, Tesla has started limited Optimus manufacturing at the Fremont factory, aiming for over 1,000 units for internal use in 2025, paving the way for market sales in 2026. This is a critical step to perfect the production process, test operational efficiency in real conditions, and accelerate upgrades before scaling up mass production. Internal manufacturing also helps Tesla fine-tune the robot based on real feedback from the factory, ensuring suitability for industrial applications. Musk also highlights Optimus's huge market potential, valued at $25 trillion, larger than Tesla's automotive business. He believes the robot can reshape the global economy by automating repetitive, low-skill tasks, reducing production and service costs, and opening a prosperous era with cheaper goods and services, improving global living standards. This is a revolutionary vision where robots will not only assist, but transform the economy's functioning. Beyond industrial applications, Tesla Optimus has also been presented at diplomatic and public events, where robots performed dances to Trump's music in front of Saudi Arabia's Prince Mohammed bin Salman and former President Donald Trump. The performance was not only entertaining but also demonstrated advancements in interaction and precise robot control, enhancing Tesla's image as a technology pioneer on the international stage. Elon Musk emphasizes that training Optimus requires massive computational resources and time. For reference, large AI models like GPT-4 cost millions of dollars in computing during training. Tesla must invest similarly or more to train the robot's capabilities in environment recognition, movement, and diverse task execution. Regarding competition, the Grok AI bot ranking, May 2025, places Tesla fifth among the world's top humanoid robot manufacturers. Boston Dynamics leads with Atlas due to complex movements like parkour. Figure AI and Agility Robotics have deployed robots in factories and warehouses, showing advantages in practical applications. Tesla remains in the early stage with a product not yet widely adopted, needing improvements in stability and production speed. Tesla began limited Optimus production at Fremont factory in Q1 2025, aiming for over 1,000 units internally in 2025 and market sales from 2026. Musk targets 1 million robots per year by 2029, increasing output by 1,000 times in 4 years, an unprecedented production ramp-up speed in robot or automotive history. Musk predicts Optimus will become a common personal item, similar to C-3PO or R2-D2 from Star Wars. With the robot industry's potential value reaching $25 trillion, Tesla expects to optimize repetitive, low-skill tasks, thereby reshaping the global economy. Introducing robots into daily life will reduce labor costs and improve quality of life, but also poses challenges for mass production and developing sophisticated control software. Musk believes that within 4 to 5 years, Tesla can produce 1 million Optimus robots annually, launching a personal robot era for millions of households. What approach is Tesla taking for Optimus in the Middle East? At the 2025 Qatar Economic Forum, Elon Musk captured the audience's attention by introducing Tesla Optimus, Tesla's ambitious humanoid robot. Although no specific plans for Qatar were announced, choosing the Middle East as the venue to showcase Optimus indicates that Musk is seriously considering expanding this robot's market into fast-growing economies eager for advanced technology. Could the Middle East be Optimus's next destination? At the event, Elon Musk emphasized plans to deploy thousands of Optimus robots within Tesla's own factories starting from the end of 2025, aiming to produce up to 1 million units annually by 2027-2029. While bringing Optimus to Qatar may not be part of the initial phase, appearing at such a major international event clearly paves the way to connect with potential partners in the region. Given the rapid urbanization and strong interest in automation in the Middle East, especially in the UAE and Saudi Arabia, the prospects for Optimus there are well-founded. In the latest videos released by Tesla, Optimus is shown not only in manufacturing environments, but also skillfully performing household chores such as stirring pots, cleaning tables, and vacuuming. This is a clear sign that Tesla does not want to limit Optimus to industrial settings. They are aiming for a humanoid robot that can serve in daily life, from assisting the elderly, managing household tasks, to handling miscellaneous chores. Is Optimus's ability to perform household tasks truly feasible in the coming years? Although these are still tests in controlled environments, the flexibility and precision demonstrated by Optimus have raised many expectations. To accomplish such tasks, the robot must possess superior sensing capabilities, excellent coordination of its hand joints, and the ability to respond adaptively to changing real-world conditions, something most robots today still struggle to achieve. Not everyone shares Elon Musk's optimism. Chris Walty, former head of the Optimus project, expressed skepticism, arguing that humanoid robots may not be suitable for production lines where high speed and absolute precision in repetitive tasks are required. According to him, fixed-arm robots, or those designed specifically for individual tasks, remain the better choice for current industrial needs. So why is Tesla still committed to developing a humanoid robot? Elon Musk has a vision beyond manufacturing. For him, Optimus is not just a work tool, it is a universal worker capable of moving flexibly in human spaces, interacting naturally with the environment, and handling various situations. Musk believes that in the future, humanoid robots will be able to replace humans in many roles, not only in factories but also in hospitals, schools, restaurants, and even space missions. How has Tesla progressed into Optimus production? According to the Q1 2025 report, Tesla has begun limited production of Optimus at its Fremont factory. This is a crucial step marking the shift from development to real-world testing. Musk confirmed that Tesla plans to deploy around 1,000 robots internally by the end of this year to evaluate performance and reliability before selling them externally starting in 2026. Do you think Optimus could become Tesla's next gold mine? If the price range of around $20,000 to $25,000 is maintained, selling 1 million robots per year could generate $20 to $25 billion in revenue for Tesla. And that's only from the hardware. Once Optimus runs on Tesla-developed AI platforms, the company could also offer additional advanced software packages, OTA updates, and subscription-based maintenance services, similar to how they currently operate with electric vehicles. This opens the door to a much more sustainable and lucrative revenue stream. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.